Good morning, everyone, and welcome back to the CNC Techniques channel. Today I want to tackle a topic that I would say is simple regarding the manual guide, which has been requested by some of you, namely the creation of an oval pocket. I will be making this pocket on the front of a piece. I have already prepared the beginning of our program, which includes a rough piece with a diameter of 225 and a certain length, but that doesn't matter much to us because we will be making the oval at the front of the piece. So, on the 225 plane at height Z0, I have set a spindle speed limit of S1000 and I have called up a 10 mm diameter end mill parallel to the Z-axis, so a face mill that works on the front. I have entered my cutting parameters to move the motorized part, and now I need to focus on creating my pocket using the aids from the manual guide. So, with the soft keys, I will look for the cycle related to milling operations, open it, and as you can see, I have all my options. As usual, drilling, chamfering, contouring, special pocketing. Obviously, we are making a pocket, so let's start with the pocketing. Operation roughing. Here, I am asked for the usual parameters, which are already quite set because I have used the manual guide for other examples. So it remembers the last set parameters. It asks me to set the stock to be removed from the bottom, which is the one before finishing. We could also set it to 0 because if we don't need to do a final finish, which often can be skipped depending on the type of operation we need to perform. It asks me for an S value, and as you can see, if I click, you won't see me entering the data. I can do it from here, but no matter how many data I try to enter, it doesn't accept them. So this is an error. This asterisk, this value should not be entered. It would be the stock to be removed. In reality, for a pocket, we know that the stock to be removed is everything. No, it's the amount of material that I need to leave. In fact, as I already mentioned, this is a translation error. It's not side material, because as you can see, in K, I have finishing material on the side. Side cutting depth. How much do I want to engage my milling cutter? We have chosen a cutter with a diameter of 10 and we will engage it for 4 mm. This is a value that will change depending on the quality of the cutter and the manufacturer's data, how many cutting edges we have, what diameter we are using, and so on. So, it should be considered as a cutting value. Axial cutting depth. We have a pocket depth of 10 mm with a cutting depth of 5 mm, expecting 2 passes of 5 mm each. It's clearly highlighted. Material for finishing is 0.2 mm, which is fine. For 1 pass, set it to 0, skipping finishing. Cutting data includes a feed rate of 200 mm min, depending on G94 or G95, with G95 set to 0.1 per revolution. Milling cutters work in min, and the feed rate is fine. When entering solid material, reduce the feed rate, e.g. set to 250, but it remains unchanged due to a manual guide limitation. ISO wouldn't have this issue. Entry feed rate from solid can be modified. Important for parameter adjustment. After data entry, decide on climb or conventional milling. I prefer climb milling, but this. And I won't perform the finishing operation. Here are other cutting data, which is the feed rate, F, set at 200 mm per minute. And this will depend on whether you use G94 or G95. If you use G95, you will set it to 0.1, which will be a tenth per revolution. Normally with milling cutters we work in millimeters per minute, and the feed rate on both sides is also fine. This has implications when the cutter enters from solid material because sooner or later at the beginning it has to enter from solid. You can reduce this feed rate. For example, I want to set it to 250. It automatically sets it the same for me. And you see, I made a mistake. It's not adjustable. So the actual feed rate remains the same. This is a small limitation of the manual guide. Obviously with ISO, we wouldn't have this problem. Now, regarding the entry feed rate when the cutter enters from solid, the manual guide allows me to modify that. It's obviously more important because when I enter from solid, I need to lower the parameters a bit. After entering all this data, I move on to the specific data on how I want to work. I want my cutter to work either in climb milling or conventional milling. We decide that I always opt for climb milling, but this, you can evaluate it yourself. I'm not a very good milling machine operator. I'm a born turner, not a born milling machine operator. Absolutely not. Maintain a 2 mm safety distance for radial and axial approaches. The mill approaches 2 mm from the piece's face. Choose direct or helical entry. Direct needs an entry angle. Helical requires angle, helix radius, and pitch. I prefer direct entry. It asks for pocket type, square, circle, or oval. Choose an oval in XC resembling a keyway. The approach is not modifiable on 3 axes. Manual guidance takes care of managing the approach. Method. You can choose to enter directly or helically. If you choose the direct method, it will only ask for the entry angle. If you ask for the helical movement, it will instead ask for the angle, the radius of the helix, and the pitch of the helix. I usually opt for this choice, which is the direct entry. You just need to be careful to give an angle that doesn't remove material where it shouldn't. In this case, the graphics help us. We insert our cycle and automatically the machine takes us to the figure of the pocket. So it already knows. We're going to make a pocket and asks us, what kind of pocket do you want to make? A square, a circle, or an oval? Well, let's choose an oval in XC, meaning at the top of the piece. As you can see, it's not exactly an oval, but something very similar to a keyway. Fanuc means this by oval, so this is the only solution we have to make an oval using the preset shapes. We can do whatever we want, but if we want to use the preset figures, this is our solution. As for how we want to make it concave, we really have no other choices because we're talking about a pocket in a base position. I want my pocket to start from Z0. I could have stepped pieces and start my pocket on an outer circumference that sinks 10 to 20 meters below the face at the zero plane of the piece, so I could start my pocket at Z20. In this case, no, let's set Z to 0. The height and depth of the pocket are indicated by the sign, meaning if I need to sink the pocket in -10, I have to set Z to -10. It's not enough to just tell it the depth, but also the direction of machining, which is usually negative lathes. Alright, here we have 2 radii, 2 circles that determine the length of the keyway. I am asked for the position in X and C of the center of the first ray. Here they are. Do you see them? Let's start by making a very simple pocket that begins from the center of our piece with a distance of 80 mm between the 2 centers. So that's the length between the 2 centers. The radii will be 20 mm and the inclination of our pocket will be 0, meaning our pocket will run along one of the 2 main axes. Let's insert the cycle and simulate it. Radial depth equal to 0. Now I'll tell you right away what the problem is. Stop. The problem is this. There's an error. How do we modify our macro instructions? Simply like this. We go to Edit. Position ourselves where there's an error. I always fall for that famous translation error. Modify T. And here there's actually a mistake in the drawing. It's the depth of the pocket we're going to create. So let's set it to 10 and not the excess material. The excess material is here. This translation error can be misleading. I assume it's a problem with my software and that it won't be found on the machine. Here you will find, I imagine and presume, but I can't verify, the depth of the pocket. Let's modify it. You see that now I have T10. Let's go back to simulation, restart, and start. There, my error has been corrected. And you see that we're making 2 passes of 5 minutes. Let's restart. Look, I go in. I widen out to -5, which is the pass I set as the depth of the pass, and then to -10. This value must correspond to this value. Do you remember the 2 masks? Now let's play a bit with the 2 instructions that the manual guide created. So the first one shouldn't be touched. The first one basically, let's just go over it again for a moment. Let's go back to EDI. If we want to see it, we just need to press modify. The first one doesn't change because it doesn't really describe the pocket itself. It mainly describes my cutting data, like radial cutting depth, which shows how much the cutter needs to remove each time it widens. Axial cutting depth, which is the depth of engagement of the cutter. And the famous T that had confused me, which is the distance between the cutting plane and the final plane, plus any excess material, if I want to do a finishing operation, and the cutting data. The game changes with the geometry of my oval shape. By modifying it, like moving H to -40, the oval starts lower. To move the key, change axis C's position by 20 mm, simulate it, and when done, it's offset by 20 mm to the left. You'll see that it's more centered because my oval no longer starts from the center of the piece. Let's look at it this way. It doesn't start from the center of the piece like it did before, but starts lower by 40 mm. If we want to raise it in this direction, we can first modify it directly from here, if we're familiar with these codes. But since we're not familiar, let's open modify. I want to move my key down or up. I just need to change the position of axis C. We'll shift it by 20 mm. Let's simulate it, and while it's drawing, it might be hard to notice, but when it's done, you'll see that it's offset by 20 minutes to the left. The same goes for A. It's easy, the angle. We can also modify it directly through the soft key using the keypad. Ditto for A, it's easy, corner. We can also modify it directly through the soft key using the keypad. Let's set an angle of 45 degrees. Maybe now it will go. Outside the shape. We'll alter it without using this soft key. This is to show you both possibilities because little by little you don't even notice it, but you start to memorize it. Stop, restart, and start. You've already got the hang of it. My key is tilted at a perfect 45 degrees. Now how can we shorten the distance between the centers? Do you remember it's 80? If you don't, let's modify the distance between the centers. The 2 radii are 20 millimeters, so the minimum distance we could have is 40. Let's make it a very squat one, 50. Edit. You see that he modified it. Simulates, reboot, and start, and we will find a more squat stick. Some of you will obviously object that this is not an oval, so I don't know if your question was referring to making an oval according to what Fanuc means in its manual guide, or an oval according to what a technical designer means, i.e. an oval with 2 circumferences connected by 2 bellies. Alright, if you want to solve this problem with the manual guide, you can do that too. So you always go to Edit to brutally delete this part. Then you go after the definition of the cycle and insert a shape, but from turning. I've done it, so I need to do it from a concave pocket shape in the XC plane. I don't know if you remember this, but here I can draw a bit of whatever I want. Now I don't have a dimensioned oval on hand, but if you have any drawing, you can write anything you want from here. Let's see if something decent comes to mind on the fly. Starting point in X is 0, starting point in C, let's make it 40, 0 because we're on Z0. Height and depth we said minus 10. Starting point in C. Let's make it 40, 0 because we're on Z0, height and depth. We said minus 10. Alright, we have our initial starting point, which we previously mentioned is negative 40. Let's take a moment to review it and make necessary modifications. Great. Now it's 40. Alright, let's draw a line to 30. Okay? Let's draw another line to minus 40. You see? As you can clearly observe, it's still taking the shape of a rhombus. So line to minus 30, and let's close the line. If you're getting lost, there's a nice tutorial on how to use the free shape in the plane, always among my videos. Go check it out and then revisit this phase. Okay, perfect. Now, as we proceed, we're adding an arc, a connection, R11, and let's increase it a bit, more than 11. Let's modify that, and here we'll add a 25mm connection. Let's change that because it's obviously wrong, and 25. Okay, and here will be my milling radius. Let's create it as demonstrated. Okay, let's simulate a restart. Start. I made a mistake. I put it in at the beginning. You see, I've inserted a whole bunch of codes here. Group end, my mistake. But it can easily be fixed without having to redo everything. You take the first block, cut it, paste it, simulate the restart, and start. You understand that with the right coordinates that I have, I just threw this in. It can become an oval. It can become anything you want. So once you understand how to make pockets, nothing stops you from drawing an elephant or anything else you want. Here we go. Let's go into simulation because 3D is always nicer. Let's enlarge the operation. Forgive me if it's not a perfect oval, but it's just about inserting the coordinates of where you want to generate the 4 circles that complete the oval, making them exactly match each other, tangent to each other, just like when you draw an oval with a compass. So you'll need the coordinates of the starting point, the end point of each circle, the center, and they need to be related to each other. At that point, you can easily draw your oval in freehand. As you can see, in this particular case, for instance, in this scenario, as an example, you can achieve this with precision. In the final part, I was a bit quicker because it's a repeat of a tutorial I did a couple of months ago. Reviewing it won't hurt you. I hope I was clear enough in explaining how to create the oval, but also pockets in general with the manual guide. It's nothing difficult. It's just about making 3 or 4. Maybe seeing where you tend to make mistakes a bit more often. You see, even in the tutorial, I didn't hide it. While editing the video, I made a little, it's a little error, but by learning to read the graphics and getting a bit familiar with the manual guide, you make these mistakes twice. After that, you get the hang of using your machine and the manual guide you've installed. There are small differences over the years between the various versions of the manual guide. I thank you for being with me once again, and I hope you enjoyed the video. If that's the case, give it a like, and if you haven't already, subscribe to my channel. Thanks everyone, and have a great day.